Lesson 1.1, Key Functions of Graphs. In this lesson, we'll look at a variety of types of functions, and then we'll talk about what their graphs look like. When we look at different types of functions, a parent function is the most basic form. We'll look at three particular models: linear functions, quadratic functions, and absolute value functions. The first parent function is a linear function, and the equation is y equals x. The slope for a linear function in parent form is 1, and the y-intercept is always 0, 0. The second common function we'll talk about in Algebra 2 is a quadratic function. The parent equation is y equals x squared. This graph is non-linear and has a vertex or turning point at 0, 0. The third parent function we'll talk about is an absolute value function. The formula is y equals absolute value of x. This is also non-linear. The vertex would be at 0, 0, or that turning point, and it's defined using a piecewise equation. Some key terminology that we'll utilize throughout the course: domain and range. If you're looking at an equation, the domain represents the set of all possible inputs and is typically your x-coordinate. The range would then be the set of all possible outputs and typically your y-coordinate. We will represent domain and range using interval notation. Let's take a look at a translated parent function for quadratics. Example 1a. What are the domain and range of the function defined by y equals x squared minus 3? Notice y equals x squared is the parent function, but then minus 3 moved the graph down on the y-axis 3 units. As we think about describing domain and range, we'll look at the graph. Domain on a graph would go from left to right. We always go smallest to biggest. So as you can see, that arrow on that left-hand side technically means it is going up, but it's also going to the left forever. So that means it would be going, or it would go all the way to negative infinity. The arrow on the right would also indicate it would go to the right forever, or positive infinity. So we say our domain for x, and we would use a parenthesis because we can't actually equal negative infinity. And then towards positive infinity, also a parenthesis. I'm going to clear my screen here, get rid of all these markings. There we go. So now let's think about range. If the domain went from left to right, smallest to biggest, the range would go from the bottom of the graph up to the top. Notice at the bottom, the smallest y value is at negative 3. And there's no open circle there, so we can conclude it equals that amount. At the top, there's arrows on both sides, so that means it will continue to positive infinity forever. Our range, which is represented by our outputs, which is y, we're going to use a bracket to show negative 3 is the lowest possible output. And a parenthesis, or excuse me, an infinity symbol with a parenthesis to show that it goes to positive infinity forever. And that's representing domain and range from looking at a graph. Let's look at some application for x and y intercepts. A car starts a journey with a full tank of gas. The equation y equals 16 minus 0.05x relates the number of gallons of gas, y, left in the tank to the number of miles the car has traveled in terms of x. What are the x and y intercepts of the graph of this equation, and what do they represent about this situation? Well, x represents the number of miles driven. So the x-intercept would be how many miles you can travel until you run out of gas. So we'll say the gas tank is empty. Let's see. So it says, what do they represent, or what are they and what do they represent? So that's what they represent. To find out what it is, we're going to set y equal to 0. So we would say 0 equals 16 minus 0.5x. And then we'd have to solve. Well, if we look at the graph, we actually can solve already, can't we? We can see that it crosses at 320. So x would be 320 miles. That's how far the car could travel before it runs out of gas. The y-intercept, y represented, what did it say up above? The number of gallons of gas. So at the y-intercept at the top, that's how much gas they had when they started. How much gas was in the tank? Originally, we'll say originally in the tank. That'd be a good one. How much gas there was originally in the tank. Wow, I'm writing really big for some reason. To find the actual y-intercept, we would technically, in the equation, let x equal 0. However, we can also look here and we can see that there were 16 gallons of gas originally. Just giving a little context to the equation and how it's represented on a coordinate system. We have a lot to talk about on this slide. Another way to describe information on a coordinate system is by looking at positive and negative intervals. Since we're using intervals, we're going to stick with interval notation, and we're only going to consider our x values that model the situation. So we're only going to look at left to right. So we always write our answer least to greatest. If you're asked for a positive interval, you're looking for values of x that give your output above the x-axis. And if you're asked to describe a negative interval, you're looking for values of x that make the output below the x-axis. Please make sure you've written all of that down. And since we're not including what the values on the x-axis equal, we're only going to have parentheses in our intervals. Let's test this out. Here's another quadratic function. Instead of y equals, we're calling it f of x equals. That's just called function notation. It's the same thing as y equals. It says for what intervals f of x equals x squared minus 9, for what intervals is that function positive, and for what intervals is that function negative. Let's look at positive intervals first. What we're looking for are values for x that put the graph above the x-axis. So notice on that left-hand side, that's above the x-axis. So on the x-axis, anything from this direction all the way to this point, the output is above. Well, on the left, that's negative infinity. But on that right-hand side where that dot is, right there, that's negative 3. So let's take a look at writing an interval on the x-axis that gives a positive output. That would be negative infinity to negative 3. And that's all on that left-hand side. But recognize there's another area on the graph where the output's positive. And that's over on the right-hand side, kind of the same idea. Notice on that right-hand side, right at that 3 value, is where it crosses the x-axis, and then as it goes up, it's going to the right towards positive infinity forever. So that's another interval from 3 to positive infinity on the x-axis where our graph has a positive output. All right, so let's do a clean slate and let's see if we can determine when we'll have a negative output. Negative means the output is just below the x-axis. And you can kind of see like this little loop right here down below. All of those outputs on the y-axis would be negative. Notice again the boundary on the left to the boundary all the way over on the right. We can actually see where those are. There aren't arrows for those. A negative interval on the x-axis, written from least to greatest, would start at negative 3. Between negative 3 and positive 3, all of our values, all of our outputs are negative. Here's another set of descriptors to describe a graph: increasing and decreasing intervals. Again, with intervals, we'll do interval notation. We're thinking x again as well. Now what you'll do is, instead of just looking at the graph overall, we're going to start on that left-hand side. From left to right, what are the boundaries for x that make the graph increase or decrease? All right, let's check an example. For what values is g of x equal to 2 minus the absolute value of x increasing? And what values is it decreasing? And then we'll talk about maximums and minimums. If we're talking about increasing and decreasing, we're going to start on that left-hand side. So we know on the left-hand side with that arrow, that means technically negative infinity is where we're quote-unquote starting. So from left to right, even though that arrow is pointing to the left, can you tell me what that graph is doing? Is it increasing or decreasing? It should be increasing. As x gets bigger from negative infinity, the graph is increasing in value. Since we don't know technically where that arrow ends, we're going to use negative infinity as our boundary. Here's where you have to be careful. Remember, we're just using x values. It increases all the way kind of to that top of the peak. But what does x equal there? It doesn't equal 2. X actually equals 0. So make sure to think about that for a minute. When x equals 0, that's at the top point for the graph. And then watch what it does. Once it reaches that point, as x gets bigger, the graph actually decreases in value towards positive infinity. It has a decreasing interval. At that turning point of 0 towards positive infinity on the x-axis. We'll quickly define maximum and minimum, and then we'll answer those questions for this absolute value function. The maximum and minimum have pretty decent sized definitions. Please make sure to write them down so that you have clarification as you're asked to do these problems. A maximum is a point on the graph, an actual ordered pair now, where the graph changes from increasing to decreasing. So it's like a peak or a high point in the function. A minimum, if you think about that in the opposite, would be when a graph changes from decreasing back up to increasing, or a low point to the graph. As we look at that example for the absolute value function, let's see if we can determine a maximum and minimum. So if a maximum is where it changes from increasing to decreasing, that would be that ordered pair at the very top. So make sure you recognize that this is an ordered pair and not just x values. So it's an ordered pair. We would say at 0, 2. So when x equals 0, we're at a maximum. And the output is 2. A minimum, also an ordered pair, or pairs if there's more than one. Notice with those arrows on each side, it goes on forever. Because of that, there's no turning point to go back up to increasing. There are no minimums to this function. Now it's time to put this all to the test. Take a look at the given function on the graph. It doesn't have an equation. It looks like it might be kind of an absolute value, but it's not the same as that absolute value shape. So it's just a given function. How many of these answers can you come up with? Could you determine the domain, the range, the positive and negative intervals, the increasing and decreasing intervals, the x and y intercepts, and when you have a maximum and a minimum? Please pause the video and see how many of these you can determine. Refer to your notes as needed, and when you feel you've answered as many as you can, press play, and I'm sorry if you can hear the birds outside right now. Press play and we'll see if we have a match. All right, let's see how you did. The domain, remember, goes from left to right. There are no arrows, therefore we're not using infinity. The boundary on the left for x is -4. And notice there's that big open circle, which means it gets infinitely close but doesn't equal. To the right on the x-axis, we have values that go all the way to +4. And with that closed dot, we use a bracket for that interval notation. The range goes from bottom to top. The smallest output I see is -1, and the biggest output is +3. Notice in this little star, it says the brackets are only allowed when you describe domain and range. The rest of our intervals will only use parentheses. The graph is positive between -4 and -3 on the x-axis, and from -1 to +4 on the x-axis. That's when we have positive outputs. The only time the graph goes below the x-axis is from -3 to -1 on the x-axis. There are 3 x-intercepts, and I've written them as ordered pairs. -3, 0 is one x-intercept, -1, 0 is an x-intercept, and 4, 0. And then I'll just go right below the y-intercept, where it crosses the y-axis, is 0, 1. Notice the graph is increasing between -2 and +2 on the x-axis. That's the only time the graph from left to right increases in value. It decreases 2 times at the very beginning of the graph from -4 to -2 on the x-axis. And then over on the right, when x equals 2 to x equals 4, the graph is also decreasing in value. Last but not least, our maximum or our high point is at 2, 3, and our minimum is at -2, -1. These are your notes for 1.1. Make sure to use them on your quiz and keep them out for your homework.